The Kodak Digital Science DC-40 camera from 1995. I've actually made a video of this when I got it, and I demonstrated it on a Windows machine. I think it was my Windows 98 gaming computer. Anyway, the DC-40 camera was one of the earlier consumer-grade digital cameras, and this was actually the basis for the Quick Take 100 and 150 digital still cameras that Apple had sold under the Apple name, the Apple Quick Take name. I got this from a friend of mine who is a former collector, and he kind of got out of it. He actually got himself a life, and I didn't. So I'm still acquiring and messing with these old things. But he gave this to me. He knows how much I love this crap, and he couldn't sell it, so that was kind of a win-win situation. Nobody wanted it, I guess. I don't know. But anyway, we're going to demonstrate the DC-40 camera, hopefully, on the, of course, the Performa 575. And, of course, this has all the original paperwork, documentation, software. It's all here. Everything is here, including a sealed copy of the Macintosh interface software. So, let's take a look. I'm going to grab the, here it is, the unused Apple serial cable. So I've already gone out and I've taken a bunch of photos with the Kodak DC-40. So to turn this camera on, open the shutter. You can hear the thing, it responds with a beep. So the image will, the screen tells you whether the flash is on or off, the timer settings, the battery level, and how many photos you have left to take. Now this little bar here, I believe, was a, I thought that was a light meter. But anyway, inside the lens here, but there's a red light in there that tells you whether or not it's writing to the media card, which is built in, integrated. It uses an integrated flash chip and cannot be expanded. On the front of the camera we have our flash, we have I believe we have a light meter that tells it how large to open the iris, and we have of course our red light, which tells us whether or not it is writing to the media card. Okay, so that makes sense. And we've got a tripod mount here and some rubberized padding. So this camera is remarkably easy to use. It does shut itself off, so you just press a button on there and it wakes up again. Runs on 4 AA's. Let's see how that goes. Yeah, it's not going to work. Here we go. Red light is on. Still on. There we go. Now it's done recording. It takes about a good solid second or two for it to record. So, now the shutter opens and closes very rapidly. So it's not like the shutter's still open while it's, you know, waiting to finish recording. The shutter has closed, so you can move the camera about. But you can't take another shot until it's done processing that image. Let's take a shot of some of these flowers that my neighbor has nicely planted. Let's see. Now there are no zoom functions on this camera at all. It's a very basic function camera. I loaded it with 4 AA batteries, and I did a couple of nice shots during the daytime. Turn it on, it starts up, there we go. And I'll just take another shot of the camera so you can see how it works. So it has an automatic flash. It takes a couple seconds. There you go, processes the image. The resolution on this camera is quite low by today's standards. So the camera's native resolution is 756 by 504 pixels. VGA is 640 by 480 as a reference. Now 1 megapixel is 1200 by 900 pixels. So we're looking at just above VGA but less than a full megapixel. And let's take a look at how bad or how good that actually looks in real life. Okay, so we're going to try our software, see if this works. Never been used before. Emphasize, never been used before. So, from 1996 apparently. So, yeah. Okay, a little old. Just one. Let's see what's going to happen. Yeah, I'm going to do a custom install. We're going to do the photo enhancer for 68K max. Do the camera extensions. I don't want the manual. And this takes up 2.5 megabytes for the camera interface software. 2.5 megabytes. Man, it's amazing what programmers could do back then with so little space. So they were so resourceful. Nowadays, I think I have desktop backgrounds that exceed the storage space that this machine offers completely. I mean, it's just crazy that this is a 250 megabyte hard drive. I mean, which was considered quite large in its day, because I mean, I've had machines with as little as, well, no hard drive, but as little as 10 megabytes of hard disk space. So it looks like the software is still good. I'm going to make a backup of these just in case they go bad on me. And they will go bad. I promise you that. So I'm going to quit the installer. We're going to launch the software. It's called Kodak something or other. Let's see. Photo Enhancer Kodak. Start that up. We're going to plug in our serial cable. Did I just turn the camera on? I woke it up. That's what I did. So I'm going to plug in the cable. I'm going to use the printer port. Just plug it in like that. Preferences. Camera type. Camera port. It's going to be on the printer port. Kodak is a DC-40. Okay. Move camera images to disk. Let's see. I think it's working. I see hourglasses showing up on the screen. So it found the camera. So there's that. We're going to do all images. There's 10. So it sees the photos. Okay. Move camera images to. I'm going to put them on my documents folder here. Put a new folder. We're going to call it Photos. I'm going to zoom in the camera so you can see the screen a little better before we get the show on the road. Whoops. Remember, we're using a 1994 Macintosh Performa 575, a 1996-ish Kodak camera. It's going to be fun. Okay, now it wants us to delete the pictures off the camera, or if we want to. I'm gonna do that. That should take about a month to delete them. So let's zoom back in. I don't know how I zoomed out or why. There we go. Oh yeah, it's still deleting. Good times. Look at the other cable. Okay. In my Documents folder, in my Photos folder, I see photos. Okay, what did I take for photos? Let's see, image number 1. Oh, I've got to bring the color depth up a little bit, I think. Opening image. It took time to do that. Look at that beautiful photo. Now this is, of course, a lovely scene that I shot here. That's it. Let's see here. Wow. Beautiful. What's my color set to? Oops, wrong one. Should be... I keep forgetting. There's like 3 different control panels for display settings. Is it under monitors? Ah, here we go. Let's bring it up to thousands of colors so we can get a better example of what's happening here. That's a little better. It was in 256 color mode. Now let's see, I got another picture here. Let's see what we got. Got 8 megabytes of RAM in this sucker. Yeah, baby. Now this is a picture of my... Oh, this is the one that we just took of the camera. Let me zoom in a little more. You can see it better. Come on now. There we go. So, you know, honestly, the image quality isn't really all that bad. Really not that bad. Let's take a look at number 3. The image quality isn't that bad. This was I wanted to see if I took a photo of like a leaf on a tree, and then left the background in there, see what it would look like. And I'm not terribly unimpressed. It's not bad. Here's my backyard. This is the backyard from my deck. How big are these? Let's see, by size. So these are 117K in size. They range from 117 all the way down to 81K. So that's that. Let's take a look. Let's go back to the small icon. There we go. Here's a picture I took indoors using the flash. I took a picture of my clock on my one right behind me. It's a little out of focus. But pretty clear. Pretty clear. I mean, you know, as clear as it's going to get. Here's a picture of the Boardman clock, which is up on the wall over there, behind the computer. And also taken with the flash. It's not a bad picture. All right, let's open one of these up, and we're going to print it out on the dot matrix printer. Now I have a friend who has the image writer. There's a driver that was made available for the image writer that allows it to produce really high quality color photos. And I don't have that driver. He offered it to me and I never got it from him. I'll have to get it. But we're going to try to print one of these out and see what happens. I mean, so we're going to set it to best quality in color, of course, and see what it can do. Okay, it's printing it in black and white, unfortunately. So we're going to try that again. So let's take a look and see what that looks like. I mean, that could be quite interesting. Okay. So check that out. Now, obviously, you've got extensive banding, but that's going to happen. The printout actually has texture to it because of the pins firing against the paper. You almost can't tell what it is. I mean, it's nasty. Will it let me print a color version of this? Let's see. It wouldn't let me. Page setup. It doesn't let me print color at all. Not a photo. Definitely not. So that's quite unfortunate. Yeah, color printing is not an option. Best, faster, or draft. There's no color option. So there's a reason for that, I'm sure. The software knows that I'm printing on one of these, and it's like, no. No, I'm not even going to let you. You are not allowed to print color on that printer.
You better make damn sure they're the same color as you are.
Oh, that Cartman. What has he got himself into now? So I got a response on the Windows 98 PC demonstration of the DC-40 camera video that I uploaded a little while ago. From a gentleman who I know and respect. I've known him for 25 years. He's the father of one of my best friends growing up. And he has worked in the vision systems industry, or machine vision industry, for roughly 3 decades or more. And he is the, I believe retired now, editor of Vision Systems Design, a publication produced by the machine vision industry for the machine vision industry. And Andrew Wilson, just a very brilliant man. He really is. And I want to share with you a response that he sent me to help fill in the gaps of where I missed in the technical details of what this camera's capabilities are and the technology behind it. Andy writes, "Dear Brandon, I enjoyed your review of the Kodak DC-40 camera, although a little less blasphemy would have helped. I would like to point out that the camera did not use a CMOS imager, but rather a CCD imager. See a family of digital cameras using still-optimized sensors," and he cites an article. "It was not until the mid-1990s until CMOS imagers were even being conceived as possible challengers to the CCD imagers, and the Kodak DC-40 was offered in 1995. The DC-40 uses or used a Kodak KAF-0400 full-frame image sensor with 768 horizontal by 512 vertical pixels, each pixel being 9 microns square. Since the photosensitive area of the device is 6.91 by 4.6 millimeters, the effective resolution that can be calculated in line pairs per millimeter, or LPMM, as 1,000 line pairs per millimeter / 2 time pixel size micrometers." I think that's... Thus, for the KAF-0400 with a 9 by 9 micron pixel size, the limiting sensor resolution is 55 line pairs per millimeter. This 55 LPMM is a measure of the sensor resolution. Sensor resolution is not the number of pixels used in the imager. 768 by 512 just tells you the number of pixels, not the obtainable resolution. Because the color version of the device used a Bayer color mask, the interpreted color resolution would be less. For its time, the NMOS-based KAF-0400 had a rather good spectral response. And that's why your snowman image looks so good. By the way, the image that you showed of the grill suffers a moire pattern due to spatial aliasing. This is caused by incomplete sampling of data in the image plane and the phase offsets of the color channels of the Bayer mask. I just knew you wanted to know this. Keep the videos coming. With best wishes, Andy Wilson, Vision Systems Design Magazine, www.visionsystems.com. And thank you very much, Andy, for your response. As always, your input is always appreciated and well respected.